Hello, everyone. My name is Victoria, and today I'm going to be talking about load balancers. But first, I would like to thank Codesmith for hosting me and Jeannie and Bracklet for sponsoring this talk. All right, so just a quick agenda for the day. We're first going to go over what exactly is a load balancer, how does it work. From there, we're going to be going over what approaches it uses to handle requests, which I promise will make sense in a few moments, and then what the pros and cons are of these approaches, and then just a little summary and some questions. Okay, so as a quick refresher for you all, relating to what is a load balancer. Essentially, we have our client and we have our server, which we're quite familiar with. Clients could be computers, phones, basically anything that connects to the internet. Sometimes it can be even refrigerators. And it's going to send requests to servers, which can also be computers. Of course, the server can also then send requests to databases, but for today's scope, we're just going to cover that client-server relationship. The server, once it receives a request from the client, then delivers content back to the client, essentially. So the problem with this system, let's say you've created a website and it's incredibly popular, yay, but you've only got one server. That server could get overloaded. It could receive so many requests. It has an extreme, slowdown, you lose clients. Or let's say it's even on fire. One server goes down, your website is down, you lose those customers. Bad news. So the solution is multiple servers. So if one goes down, we've got backups on backups, which we always love in coding, software engineering things. But how do clients know which servers to go to? This is where load balancers come in. So load balancing is essentially the process of distributing that network traffic across kind of multiple requests along to multiple servers. It allows, kind of just that nice flow of information. It also prevents that system failure that I mentioned earlier. So if one server goes down, our top one over there, then the client's request can get redirected to server number 2 so we don't lose that client. How exactly do load balancers work? Essentially, load balancers, they're reverse proxies. Reverse proxies are essentially an application that sits in front of the backend and forwards requests onto the clients. So the load balancer does this specifically by presenting a virtual IP address. How does it determine that that request of information on? It does it using an algorithm. So what exactly is the algorithm that the load balancer uses to direct requests? It depends. There are many different algorithms that load balancers can use to decide on how to determine which server each client's request gets sent to. And of course, each algorithm comes with its own pros and cons. So while there are many options for algorithms that load balancers can use and many different iterations, there are 4 very common ones that tend to pop up that I'm going to be touching on today. We have our round robin, least connection, least response time, and IP hash. So to start is round robin. Round robin is the most commonly used algorithm for load balancers. Essentially, it implements a queue, which we're all very familiar with. So that first server there receives a request, and then once that request is received, it goes to the back of the queue. Server 2 gets a request, and onwards and onwards. One of the biggest cons of this approach is what happens when one client's request persists longer. So let's say server 3 is handling client request 3. That request is taking a really long time. It's computationally expensive. And so then request 7 comes in and it's still trying to handle request 3. And we have server 4 just kind of chilling here, not doing anything. This is where the algorithm of least connections comes in. So rather than implementing just a straight up queue, it also adds in some logic that essentially sees which server has the least amount of connections on top of that. So it essentially works the same way, but then if server number 3 is still handling request number 3, then request number 7 can go on to request server number 4. This solution works best when there's kind of a variety of request types that are coming in, so you can't quite predict. If you have the same kind of request every single time, it's a bit of overkill to add in least connection, but when everything's kind of all over the place, this is really where you would want to consider this. The largest con with this solution is the difficulty in implementing it. Queues, very straightforward, versus this one, the load balancer has to keep track of who's in what order of the queue, but also who's getting what response time. So it's not just seeing the request going in, but also the responses going back out that it's tracking. There is another consideration here. So let's say a server, it's not breaking, it's still handling requests, but it is significantly slowing. This is where the least response time algorithm comes in. So instead of only calculating which server has the fewest connections, it's also calculating which server is taking like a longer time. This solution is best when response time is absolutely the most important. I will say the biggest con on this, it kind of leads in with least connection. It's difficult to implement, and it's also really difficult to troubleshoot. So essentially, you can't really predict which server is doing what, so you don't necessarily know, is your algorithm working, is your server down, because everything is so unpredictable. It's essentially, it's non-deterministic, so we just don't know in advance. So just a little bonus I have here. What happens if, let's say, we've got one mega server and then 2 smaller servers? This is where the weighted option comes in. This is something that you can implement on top of all of the options we've covered so far. Essentially, it boils down to you give one server extra weight. So let's say in our round robin queue, server 1 would get placed 1 and 2 before kind of moving down to the bottom of the queue and so on. So it just takes into account that power there. So far we've covered algorithms that they can be built off one another. The IP hashing approach is actually entirely different. So we're all quite familiar with hash tables at this point. Essentially, this algorithm takes in clients' IPs and runs it through a hash table, and it sends it to its kind of corresponding server there. So each time a client reconnects, they'll be sent to that same server, regardless of how many connections there already are. So server 4, once again chilling. Server 2, it's got a few more connections, but they are kind of that same consistent connection going on there. The major benefit of this approach is that if a client connection is disrupted, so number 2 over there, they're going to be returned to that same server if they reconnect. This is really something to consider if it's important that a client has a session that is potentially still persistent across their lost connection. One that came to mind for me is kind of online gaming. You want them to redirect to that same online server. Of course, this approach does come with its own kind of drawbacks. Notably, what we had covered so far, let's say one server goes down, those clients could potentially lose that connection. Or let's say server 2 has so many connections, meanwhile server 4, it has nothing going on. I will say with that, one of the ways around that is, again, backups on backup. So you have kind of backup load balancers going on here, but it is something to consider. So just for a conclusion, load balancers, super useful way to manage those requests from multiple clients to those multiple servers. There are many algorithms to choose from and how those requests are directed. So it's really up to you to decide what makes sense in your specific scenario. We have the round robin, least connection, least response time, and IP hash methods, but I would definitely recommend looking into some other ones as well. There's a really interesting kind of wide expanse of options in the universe, and each kind of comes with its own pros and cons. These are my resources if you'd like to do any extra reading on this, and if you'd like to contact me, there I am.